Hi, I'm Pravir Malik, and I'm the founder of Deepwater Technologies. And I've been working on a mathematics to unify organizational development and innovation. And today I'd like to apply a generalized equation for innovation at the cellular level. Now, this generalized equation of innovation that I had derived previously is depicted as the following. So we have innovation, and then I define a subscript orientation X. And the objective of this equation of innovation is basically to integrate together or to synthesize the dynamics on various levels that inform any single organization. So I start with the outer or surface layer, which I call the untransformed layer. And at this untransformed layer, the dynamics are characterized by a set X. So this is the same X as this X here, and I specify the untransformed set by the subscript U. Now, so what we have here is a set of possibilities or characteristics that specify an untransformed organization. And when there are certain patterns that are overcome, specified by p to the base x, so when these patterns are overcome, what we do is we set into place the dynamics to integrate or to begin to synthesize with a layer, the metal level 1, which informs the outer layer. And this layer, metal level 1, the dynamics of this layer are specified by what I call a signature to the base x. And this signature essentially gives insight into uniqueness of the organization. The uniqueness cannot be tapped into unless some habitual patterns are overcome. When this signature begins to become an independent force, we put into place the conditions to move to metal level 2, and metal level 2 is basically specified by a set of architectural forces that hold true for that set X. And I have this set of architectural forces I depict as S system to the base large X, and there's a difference between large X and small x. And when this force becomes impersonal, then the conditions to move to metal level 3 are put into place, and at metal level 3 the dynamics are specified by a generalized equation system to the base x. And previously I've derived detailed equations for each of the orientations to do with each of these levels. So there are 4 sets of equations for the 4 different orientations. So this is the core of the generalized equation for innovation. And here I want to mention that X is an element basically, or can be thought of as derived from a set of orientations which are the physical, vital, mental, and integral orientations. And the large X are, in a sense, seed sets or supersets from which everything else diversifies. And this is an element that, in fact, the physical, vital, mental, and integral derive from. And we can think of this physical as being presence or service, vital as deriving from a original meta-level characteristic of power, mental deriving from a meta-level characteristic that applies across a system of knowledge, and the integral deriving from love or nurturing. Now, this equation, essentially what we're saying is that innovation begins to occur when this untransformed set X begins to transform through the action or the synthesis of these meta layers. And there's a function that I had specified called the transformation circle, and the action of this transformation circle takes that initial set X to the base u and transforms it so it becomes x to the base t. So the action of innovation really is to take xu, which has certain characteristics or parameters that are untransformed, and transform them into a new set which allows the basis of innovation and innovation to occur in a very different way. Now if we look at the transformation circle in a little more detail, so here we're talking about complex systems, systems that are human systems, teams, corporations, markets, larger systems, and the transformation circle I had previously depicted as having 4 concentric circles. The outer layer was the untransformed metal level 1, metal level 2, and the inner core was metal level 3. And the transformation circle can be thought of as a kind of a clock. And as time proceeds, there is a sinusoidal function that is initiated that begins to integrate more and more of these layers together until there's a synthesis of these different layers so that in effect the untransformed layer becomes something totally different. Now I had specified that this transformation circle of the complex system is some function of this sinusoidal wave and of the Euler function E, because it progressively increases, but increases within a boundary that's specified by pi being a sphere. And so it was a function of sine E and pi. Now, when we think about action at the cellular level, the prerequisites are that the 4 bases from which this entire mathematics is derived, so if we think about this set of architectural forces, these 4 bases should exist within the cell as well, and the question is, does it? So on conducting research of molecular plans within the cell, any cell, so this is a cell in any living form on Earth, we find that there are 4 molecular plans by which every nano level machinery within the cell is derived. And these 4 plans can be thought of as nucleic acids, proteins, lipids, and polysaccharides. So when we think about the personality of these molecular plans, then really nucleic acids is that part of the cell that really houses information. So the genome is housed in nucleic acids, the DNA and RNA, for instance. And within there is specified exactly how the cell needs to behave under any circumstance, what it needs to do, how it needs to replicate itself, how it needs to live. So all the knowledge, all the information that the cell would ever need is contained within nucleic acids. So if we think about nucleic acids and the personality of it, then we can say it's some kind of a precipitation of this characteristic of knowledge that exists as a meta characteristic in the system that we exist in. And by the way, I had previously, for those who have followed the mathematics I had derived earlier, we had independently come up with these 4 characteristics that apply at the system level for any organization within the system, for any progressive organization within the system. So similarly, we can see that nucleic acids is corresponding to that base of knowledge. When we think about proteins, proteins are really the workhorses within the cell. And every, by the way, nucleic acids contains all the information on when to make a protein, how to make a protein, and there are about approximately 30,000 different proteins that can be created within the human cell. And these proteins are workhorses. They do all the conceivable work that you could envision that needs to be done for a cell to sustain itself and to replicate itself. And so we would think of this as a precipitation. The personality of proteins is such that it's a precipitation of that presence or service aspect that we find in the metasystem within which we exist. When we think about lipids, lipids are fats or oils, but at the cellular level they behave in a remarkable way, and that is to create boundaries around compartments. So even a cell is contained within a lipid boundary, and then specialized areas within a cell, whether it's mitochondria or the nucleus, is also contained within a lipid boundary. And we can think of this lipid boundary as creating exclusive areas of work, separating different kinds of work. So it's basically, over the long term, creating this basis of harmony, mutuality, nurturing, by which the cell can do what it needs to. And so it's a precipitation. Lipids can be thought of as a precipitation of this aspect, this meta-level aspect of nurturing. And when we think about polysaccharides, polysaccharides are long chains of sugar molecules that have hydroxyl molecules on the surface, and they are differentiated from regular sugar molecules because these hydroxyl molecules allow different kind of containers to be created, and these are in essence polysaccharide containers that have a tremendous amount of energy and power within them, by which all the work in the cell can be done. And further, they also provide the cell with a lot of strength, in that if we see any kind of very strong structure like a tree or a lobster shell, for instance, it's basically because of the polysaccharide component. So what we're saying is that this aspect of power or energy precipitates at the cellular level as the molecular plan of polysaccharides. So we have remarkably these four bases that on which this entire mathematics for organizations is derived, also existing at the molecular level, which means that we could conceivably apply the same mathematics and the same equations for innovation at the molecular or cellular level. Now, when we think about what that equation might look like, I would hypothesize that equation is pretty much the same. The primary difference is in the transformation circle function, and whereas over here at the complex system level, what we have is a transformation circle that really acts from the U to the M3 level. So there's choice that has to be exercised by an organization at the untransformed level to begin to integrate to higher and higher levels. So the direction of integration is from U to M3, and further the specific way in which this integration takes place, I hypothesized, is through a sinusoidal wave, the Euler function within a boundary pi. But when we think about the transformation circle at the cellular level, I would hypothesize that there's a automaticity that's taking place. So in fact, that integration is driven by from M3, the inner core, and so the direction of integration is different. It's from the inner to the out. So there are certain rules that are specified by which the outer automata or machinery directs itself, if you will. And further, I would say that if we think about this as a clock, as we have thought about this, then this integration could be thought of in different ways, but it's a function of, if we think about polar coordinates r and theta within this circle, then we could say that at theta equal to 0 or time equal to 0, that integration could be complete. That means that the radius is already existing across all four layers, or it's possible that at theta equal to 90, for example, is when the integration takes place. So it takes time, or it could take a full circle. But the point being is that the integration of synthesis, while it occurs from the inner out, it occurs at some value theta, and the synthesis is really characterized by that radius r that cuts across all the four layers. So the difference at the cellular level that I hypothesize is that we have this automaticity, just summarizing, and so we have Tc at the cellular level, which is really a function of r and theta. And again, the integration is taking place from m3 to u as opposed to from u to m3. So this equation remains the same, but the way the transformation circle works is the difference.